Hey there, this is just an introduction on the trigonometric functions, or a review if you've already seen them. So the three that I'm going to talk about is the sine, the cosine, and the tangent. So when you're talking about a right triangle, you want to talk about the hypotenuse. You want to be able to identify the hypotenuse, the adjacent, and the opposite. This symbol right here, that means theta, or the missing angle. So that helps us determine what is the adjacent and what is the opposite. The hypotenuse will never ever change, because if you remember, the hypotenuse is always across from your right angle. So I'm just going to put the H for hypotenuse. So what matters here is theta. So if I would connect the two lines of the triangle with an arc, and if you're visual, sometimes even coloring in that arc, that angle, you can now identify your opposite and your adjacent. So this point right here, let me get a different color. This point right here touches this line. This line is the hypotenuse. What always touches the angle is the hypotenuse and the adjacent. Adjacent means next to or touching. So what will always touch the angle you're talking about will be the H and the A, hypotenuse and the A. Therefore, leaving us, if we would go directly across from that angle, would be our opposite, or O. So we're going to identify a few of those H, A, and O's on a couple triangles here before we get to sine, cosine, and tangent. So this says identify the parts of the right triangle, the hypotenuse, adjacent, and opposite of angle A. So on my diagram, I don't have anything written, a theta or a degree or anything, but I know that I'm talking about angle A. And angle A is this right here that I'm coloring in right now. So I'm to identify my H. Well, I always usually do my H first, because I always know my H is always across from my right triangle, my right angle. Now adjacent I do next, because what always touches the hypotenuse is the adjacent. So what always touches that arc on your angle will be your hypotenuse and adjacent. So once you know hypotenuse, the adjacent comes next. And then opposite theta would be your opposite. So there's your A, O, and H for this triangle. Now on this triangle, it says for angle C. So I'm going to put my arc at angle C, and I'm going to identify the two lines that are touching my arc. And I always know that across from the right triangle is my H, so the other line has to be my A. Leaving the angle across, or the line, the side opposite it, or across from it, is opposite. Easy for me to say, just like old times. Alright, so identify the parts of the right triangle. Now notice here they're giving you a degree. So you've got a 51 degree here. So on this triangle, this angle right here in green is 51 degrees. So I still have to identify my O, A, and H. Not in that order, but first we identify our hypotenuse. So there's my H. And if you remember, what always touches that arc would be your H and your A, leaving that wonderful O for opposite. And I think this is the last one I'm going to show you. So 59 degrees, there is my lovely little arc, and my angle that I need to know that it's 59, so I need to identify my H, A, and O. Be careful, because always notice this triangle is kind of upside down. Across from the right angle is always your H. What is touching that? Well, this is my H, where I just did in brown. This is my H. So what other line on the triangle touches that arc has to be your A, leaving X to be my O. So rewind if you need to see that. Try it a few times without me, see how you do. So now we can identify the sides of a right triangle. We can apply sine, cosine, and tangent. So the Greek letter that looks like this that I just circled in brown and green is called theta. It's pronounced theta, and it means the unknown angle. So when I say theta, I'm talking about that symbol or the unknown angle. So in this triangle, I need to identify sine. Sine is always going to be opposite, and I'm going to abbreviate a little bit more, over hypotenuse. So sine, this is my hypotenuse, this is my opposite. So opposite over hypotenuse. All I'm doing is figuring out what sine is on this particular triangle. Opposite over hypotenuse. And we can abbreviate that with so. Sine is opposite over hypotenuse. So the next trig is cosine. Trig ratio is cosine. Cosine is adjacent over hypotenuse. So here's my theta. What always touches the arc? Your hypotenuse and your adjacent. So cosine adjacent over hypotenuse. Numerator over denominator. And then the third one I'm going to talk about is tangent. And let me go back to cosine real quick. We can say cosine is adjacent over hypotenuse. So tangent, we can say toa. So that's opposite over adjacent. Tangent is opposite over adjacent. So that's toa. So why do we need to know that? Opposite, this is just another way to see it. Sine, cosine, and tangent. Those are the abbreviations, by the way. We just take the first three letters. Even though this says sin, we still call it sine. So opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. So a way to remember this is SOHCAHTOA. Sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. And I know some of you are asking, why do you have an old hippie dude on your screen? Well, let me tell you that. Because another silly way to remember SOHCAHTOA is to use the abbreviation of some old hippie came hopping through our apartment. And you can make your own mnemonic device if you need, but some old hippie came hopping through our apartment. Sine, cosine, and tangent. So how do we find sine, cosine, and tangent? And we're just going to write it in fraction form. So the directions here are to find the sine, cosine, and tangent of angle A. So the first thing you need to do is mark your angle A. So I put my arc here, and I always know the two things that touch my arc are going to be hypotenuse and adjacent. So what's always across from the right angle? Yep, hypotenuse. What always touches the arc? Hypotenuse and adjacent, leaving that 9 to be our opposite. So sine is opposite. Opposite is the number 9. So 9 over hypotenuse, 10.8. 9 over 10.8. That's really sloppy. Sorry about that. Here, I'll clean it up. I know you just want to see my writing. 9 over 10.8. That's a little bit better. Cosine is adjacent over hypotenuse. What is adjacent? Well, that's my 6 over my hypotenuse, 10.8. And then finally my tangent, my O is 9 and my adjacent is 6. So by labeling your triangle, your O, A, and H, and physically writing those letters, when you go to find the sine, cosine, and tangent, you just have to look at the letter that applies. Opposite is 9, adjacent is 6, so on and so forth. So I'm strongly encouraging you to label your triangles. So one or two more examples. Find the sine and cosine tangent of angle A. So I'm going to start by marking my angle A. And I know the two lines of the triangle that touch my angle A are my hypotenuse and adjacent. Always across from the right angle is hypotenuse, and the other one that touches my arc is adjacent, leaving my 8.2 to be my opposite. So what is sine A? My opposite, 8.2. So all I'm doing is filling in the formula now. 8.2 over 24.5. What is my adjacent? Well, my adjacent is 23.1. My hypotenuse is 24.5. And my lovely tangent, opposite, 8.2 over adjacent, which is 23.1. SOHCAHTOA. So that is the lovely, brief lesson on SOHCAHTOA. And I say brief, it took me 11 minutes, but you got some good stuff in here.